Hello, guys and girls. Today it's a Friday and we have a Cambridge International Mathematics video tutorial. In this video, we'll be revising the 2020 final exam, paper 2 extended. Alright, before we start, I would just like to let you know that on Fridays, we will always have a Cambridge Mathematics video tutorial. So if you're new here, just make sure you subscribe to the channel and turn on the notification so that you can be notified when a new video is available. Also, if you like our videos, please do click on the like button, or you can even say something on the comments. Why? Because we get feedback on if we really should keep on posting Cambridge Mathematics video tutorials, or people are just not interested in these student tools video tutorials. You don't have to do it all. Either you like or you say something on the comment section. But if you got time, of course, you can do it all. Okay, with that said, let's dive into today's revision. All right, so we have question one. Question one says, find the highest common factor of 60 and 90. So we have to find the highest common factor here. And let us first define what a factor is. A factor is a number that divides into any given number without leaving a remainder. So we want to find the highest common one between 60 and 90. So it's 60 and 90. We want to find the highest common factor between these two numbers. So the first thing that we'll do is list the factors of 60. And then next we'll have to list the factors of 90 and then identify the highest common one. So we'll start with the factors of 60. Factors of 60, we have 1 and 60. We have 2 and 30. We have 3 and 20. We have 4 and 15. We also have 5 and 12. Yes. Do we have more factors? Yes, we have a 6 and a 10. So these are all the factors of 60, the numbers that divide into 60 without leaving a remainder. So next, we will have to find the factors of 90. Factors of 90, we have obviously 1 and 90. We have 2 and 45. We have 3 and 30. We have 5 and 18. We also have 6 and 15. And then we have 9 and 10. So these are all the factors of 90. And what we are looking for is the highest common one between 60 and 90. So what's the highest common factor? But before we get to that, let us first identify the common factors. The common factors, what do we have? We have 30 and 30 over here. That's common. We have 3 and 3. We have 2 and 2. Obviously 1. We have 15 common factor. We have 6 and 5. And then we have 10 is the common factors. So from these common factors, which one is the highest? I can say 30 is the highest common factor here. So the highest common factor of 60 and 90 is 30. So HCF is equal to the 30. So that is our answer to question 1. All right, let's move on to question 2. Question number 2, insert one pair of brackets to make the statement correct. Right, so we're given that expression and we're supposed to insert a pair of brackets to make it true. So we have 5 minus 2 plus 3 multiplied by 2 equal to a negative 5. So we are supposed to insert a pair of brackets here so that this statement becomes true. Let us first put our brackets over here, see what we get. So if we have 5 minus 2 here, we have a positive 3. And then here we have 3 multiplied by 2. So that means that's a plus 6. So 3 plus 6, that is not equal to a negative 5. So we cannot say our brackets can be there. So we'll start afresh. And see what happens if we put our brackets over here. So now we have 5 minus 3 plus 2. So 3 plus 2, that is a 5. Multiplied by a 2. So 5 multiplied by a 2, that is a 10. So that means we have 5 minus a 10. That is equal to a negative 5. So that means if we were to put our brackets, we would put them over here to make this statement true. So that is just how we do it for this question. All right, let's move on to the next question. Question 3. Question 3, we have P and Q, and we also have a question which says find 2P minus 3Q. So we have to find 2P minus 3Q. All right, let us do that now. So we have 2 multiplied by P. So P, we have 2, 3, and then we have to subtract 3Q. 1, 6. So 2 multiplied by 2, that is a 4. And then 2 multiplied by a 3, that is a 6. So have this. Now we have to subtract this. 3 multiplied by a 1, that is a 3. 3 multiplied by a 6, that is an 18. Okay, now we have to subtract here. So this is equal to 4 minus 3, we have positive 1. 6 minus 18, we have a negative 12. And that is just how we do it for this question. Easy peasy. Next question is question 4. Question 4 says, write 0.72 as a fraction in its lowest terms. Okay, so we have a decimal 0.72. 0.72. We have to write it as a fraction in its lowest form. So to change this into a fraction, we have the ones here, we have the tenths, and here we have the hundredths. So that means we actually have 72 over a 100 because of this. So that's the fraction we have. And then we have to simplify this fraction to its lowest form. So to do that, we have to divide with a 4 on the numerator and the denominator. So we'll divide 100 with a 4. So when we divide 100 with a 4, we get a 25. And then when we divide a 72 with a 4, we get an 18. All right. So now we have 18 over 25. Can we simplify this a bit further to a lower form than this? No, I don't think we can. That's just how it is. It is now in its lowest form. So our final answer is 18 over 25. So 0.72 as a fraction in its lowest terms is an 18 over 25. Now let us move on to question 5. Question 5. The mean of a list of 9 numbers is 6. So we have a mean of 9 numbers, which is equal to a 6. When the 10th number is included in the list, the mean is 5.5. So that means one more value was added on the list of 9 numbers. Therefore, the mean now is 5.5. So the question says, find the value of the 10th number. Okay, so let us focus on the mean of the 9 numbers. So we're told that there are 9 values on a data set. And then the mean of those numbers is equal to a 6. So how do we get the mean or the average? So we get a mean by adding all the values in the data set. We will call that the sum of the values in the data set. We will call that S in this case. So we have the sum of the values in the data set. We divide them by the number of values that are in the data set. And in this case, that will be equal to a 6. So the sum of the numbers in the data set over the number of values in that data set, which are 9. So that is equal to a 6. We want to find the sum of the values in the data set. So to get this, we have to multiply with the 9 both sides such that this will cancel this. And then we have the sum of the values in the data set equal to a 6 multiplied by a 9, that is equal to a 54. So that means in the first case, they had a 54 over a 9. When they were looking for the mean, they got a 6 because 54 divided by a 9 is equal to a 6. So that's how it was. But then on the second case, we are told that a 10th number is added to the list. So we will let that number be an x. So let's say 54 plus that other number, which is included in that data set, the first set, we'll let it be x. So when we want to find the mean of this, we divide that with the number of values in the data set. And on the second case, we have one more. So which means it's the 9 plus this one. So that means it's a 10. And the mean of this one is equal to a 5.5. So what we're looking for is this x. So let us find this value of x. So with this expression, we will multiply with a 10 both sides. So this 10 will cancel this 10 such that here we have 54 plus x equal to a 5.5 multiplied by a 10. So that is a 55. And then we have 54 plus x. 54 plus x on this side. We want x the subject. We will have to take the 54 from the left hand side to the right hand side. So we'll do that by subtracting 54 here and also subtract 54 on the right hand side, such that this will be 0 because 54 minus 54 is a 0. And then x will be equal to a 55 minus 54, that is equal to a 1. And then what does that mean? The value which was added into the data set, or the 10th number which was added into the data set, was a 1. So the 10th number is equal to a 1. And that is just how we do question 5. Okay, let us move on to question 6. Question 6, we're given the triangle and we're supposed to find the length of the hypotenuse of the triangle. So we know this is a 90 degrees. So we will use the Pythagoras theorem to find the value of the hypotenuse. So we know that a squared plus b squared is equal to c squared. So c is the hypotenuse. Let us call this a and this one b. So a squared, we have the square root of 6 squared plus b squared, we have the square root of 3 squared is equal to c squared. So now we have this, and then the square here is going to cancel the root, such that here we will have the 6. And then here it will cancel the root as well, such that we will be left with a 3. So this will be equal to c squared. So 6 plus 3 is equal to 6 squared. So what is 6 plus 3? That is a 9, equal to c squared. So to get rid of the square, we will have to find the square root of this. And what we do on the right hand side, we also have to do it on the left hand side. So c will be equal to, the square root of 9 is equal to a 3. So that means the hypotenuse is equal to a 3. And that is just how we find the value of the hypotenuse. Next is question 7. Question 7, solve the simultaneous equations. So we have these two equations and we're supposed to solve them simultaneously. U minus W equal to a 9 and 3 plus W equal to a 19. So we know that we have 3 methods of solving equations simultaneously. We have elimination, we have substitution, and we have the graph method. So which of these methods can we use to solve this case? So I think in this case we can use the elimination method. So how are we going to do that? I want us to eliminate these terms. So how are we going to do that? We'll put some brackets over here and then take the coefficient of the second equation and put it over here. And then take the coefficient of this u on the first equation. So u, the coefficient of u is 1. It's not there, but we know that there is a 1 over here. So the next step is to multiply out this. So for the first equation, we have 3 multiplied by a u, so that is a 3u. And then 3 multiplied by a minus w, so that is a minus 3w, equal to a 3 multiplied by a 9, that is a 27. And then on the second equation, we multiply out. Because we're multiplying with a positive 1, it will remain the same. So we have 3u plus a w equal to a 19. So we have that, and then we subtract. So 3u minus 3u, that is a 0. So you can see the u has been eliminated. So now we have minus 3w subtract positive w. So that is more like a negative 3 minus 1. So what is negative 3 minus 1? That is equal to a negative 4. So that means here we have negative 4w. And that is equal to a 27 minus a 19. So that is equal to an 8. So now we have minus 4w equal to an 8. And we want to make w the subject. To make w the subject, we have to divide with a 4, negative 4. And also on the right hand side, we divide with a negative 4. So this will cancel this, such that w will be equal to a positive 8 divided by a negative 4. That is equal to a negative 2. And now we have the value of w. What we don't have is the value of u. So we'll use the first equation to find the value of u. So the first equation was u minus w equal to a 9. So now we know the value of w equal to a 2. We will use that in this equation. So u minus w is equal to a negative 2. So we'll put that in brackets, negative 2 equal to a positive 9. So now u minus negative 2. So this actually changes to a plus. So u plus a 2 is equal to a 9. And then we want to make u the subject. So to make u the subject, we would have to subtract 2 here and also subtract 2. This will be a0, such that u will be equal to a 9 minus 2, that is a 7. So that is just how we solve these equations simultaneously. W is equal to a negative 2, and then u is equal to a positive 7. Next, we have question 8. Question 8, the scale of a map is 1:250,000. So that's the scale. 250,000. Find the actual distance in kilometers between two cities which are 52 centimeters apart on the map. So on the scale, 1 centimeter represents 250 centimeters on length, or the actual distance. So we want to find the actual distance of a 42 centimeter representation on a map. So we're told here we have 42 centimeters. We want to find this distance on the actual map. To get this 42, we have to multiply this one with a 42 over 1. So we'll do the same thing on the other side. So we'll multiply this with a 42 over 1 to get this value. So 250,000 multiplied by a 42. So we have a 250,000 multiplied by a 42. 42 over 1 is still the same thing as 42. So that is a 10,500,000. So we have 10,500,000. Alright, so that is the actual distance on land. And this is actually in centimeters. So what we want to find is the actual distance in kilometers. So we have to find the actual distance in kilometers. We know that 100 centimeters is equivalent to 1 meter, and 1000 meters is equivalent to 1 kilometer. So that means that is actually equal to a 100,000 centimeters. So that means we have to divide this with a 100,000. So 10,500,000 divided by a 100,000. So this 0, so this one, this one, this one. So we have a 105 kilometers. So this is the actual distance in kilometers between the two cities, which are 42 centimeters apart on the map. And that is just how we do question 8, ladies and gentlemen. Let us move on to question 9. Question 9, a set of x is less than 4 and x is an integer. Find the smallest possible value of x. So we're told that a set of x is less than a 4 and x is an integer. So we can say this is something that's like this. We can say that x is supposed to be less than a 4, but also x is supposed to be greater than a negative 4. So now let us write that set of integers which are between negative 4 and positive 4. So x is greater than negative 4. So that means we're starting from negative 3, negative 2, negative 1, 0, 1, 2, 3. We're not getting to 4 because it is less than 4. So that is our set. So the question was, find the smallest possible value of x. So the smallest possible value of x is negative 3. So our answer here is negative 3. Now we're done with question 9. Let us move on to question 10. The first 4 terms of a sequence are 20, 13, 6, and -1. Find A, the next term. All right, so here we have a sequence 20, 13, 6, and -1. And we're supposed to find the next term after -1. All right, so how are we going to do that? First step will be to understand this sequence. So in order to understand this sequence, we will first find the first differences so that we can check if it's an arithmetic or maybe a different sequence. Okay, so to find the first differences, term 2 minus term 1, that is 13 minus 20. 13 minus 20, there is a -7. And term number 3 minus term number 2, so that is 6 minus 13. That is also a -7. And term number 4 minus term number 3, -1 minus 6. So that is still a -7. So here we're dealing with an arithmetic sequence. So that means, again, the difference here will be a -7. So the simplest way to find the next term after -1 will be to add -1 and -7. So what is -1 plus -7? -1 plus -7, that is a -8. So for A, the next term is -8. All right. We also have B. B says find the nth term. The nth term. So what do they mean when they say find the nth term? They actually mean find the general term of the sequence. So we already know that we're dealing with an arithmetic sequence. So how do we find the general term or the nth term of an arithmetic sequence? We actually have a formula that we use to get the nth term of an arithmetic sequence. That formula is this one, a plus n minus 1 multiplied by d, where a is the first term and d is the common difference. So now to find the nth term here, let us use the information we have. So the nth term is equal to a, which is the first term. Let us write it like this so that it will look like an a, not a 9. So the first term here is 20. So here we will have 20 plus n minus 1 multiplied by d, which is the common difference. Common difference is the -7. So we will have -7 here. The nth term equal to 20, -7 multiplied by n, so that is a -7n. And -7 multiplied by -1, that is a plus, because we're multiplying a negative and a negative, so that is a 7. So now we have the nth term equal to, I want us to start with the -7n, so let us do that. We'll have -7n. Here we have 20 plus 7, so that is a plus 27. The nth term of this sequence is -7n plus 27. And that is just how we do it, ladies and gentlemen. Now we move on to question number 11. Question number 11, we have a question which says, make u the subject of the formula, and we're given that expression. So we have this expression, v squared equal to u squared plus 2as. And we're supposed to make u the subject of this expression. So how are we going to do that? So because we have u on the right hand side and we also have 2as, we want to be left with the u on the right hand side. So we will have to take 2as from the right hand side to the left hand side. So how are we going to do that? We will do that by subtracting 2as, because it's positive on the right hand side. So we'll do that on the right hand side and also do it on the left hand side. We'll subtract 2as such that this side we will no longer have this. But then on the left hand side we will have v squared minus 2as equal to u squared. So now we have u squared. We want to make u the subject, not u squared. So to get rid of the square, we would have to use the square root. So we use the square root on the right hand side. We also have to use the square root on the left hand side. So this square root will get rid of the square such that here we will have the u. So it's now the subject. So now we have u, and u is equal to the square root of v squared minus 2as. We can even write it like this and say u equal to the square root of v squared minus 2as. And that is just how we make u the subject of the formula. All right, now we move on to question 12. Question 12 says factorize completely, and we're given that expression. We have 2a minus b plus 2ax minus bx. So we're supposed to factorize this expression. So guys and girls, we know we have so many ways of factorizing depending on the expression that you are given. But in this expression, I think one way that could work is to factorize by grouping. So actually, I don't think, I know that the one way that would be the easiest is to factorize by grouping. So let us start doing that. So I want us to rearrange this expression first so that we can factorize. We will have two groups. So we will have this term 2a and plus 2ax, this one. That will be the first group. And then the second group will be minus b, this one, minus bx. So actually I haven't changed anything. I just grouped these terms into two groups. So I will factorize by grouping. But so the first step will be to factorize the first one, and then the second step will be to factorize the next group individually. Now let us start with the first group. So we have 2a and 2ax. So what is the common factor here? We are factorizing the first group. So the common factor on the first group will be 2a, because we have 2a here and 2a here. That is the common factor. So what do we put in our bracket? We will have 1, because 2a multiplied by 1, that is 2a. And then next we will have plus x. Why? Because 2a multiplied by x is a 2ax. And then we close our bracket. So now we have the second group. We will factorize that group as well. So what is the common factor on the second group? That is the b. So we will have a minus b here. And then we open a bracket. To get minus b, we have to multiply minus b with a positive 1. And then to get minus bx, we have to multiply minus b with a plus x. So we close the bracket. So now we have something like this. Please do note that we have 1 plus x over here and 1 plus x over here. And we have the terms that we have factored out here. So what is the next step? The next step will be to put the terms that we have factored out in one bracket. So we put them in one bracket. That is 2a minus b. So those are the terms that we have factored out. And then we have the 1 plus x, which is here and over here. So we will also have that 1 plus x. And that is just how we factorize this expression. That is 2a minus b multiplied by a1 plus x. And that is our factorization by grouping. So next question is question 13. Question 13, we have a question which says find the x value of a. We have 3 to the power negative 3. When we have 3 to the power negative 3, that means it is equal to a 1 over 3 to the power 3. Why? Because we have a negative exponent. So we will have a 1 over 3 to the power 3. So what is that equal to? It is the same as 1 over 27, because 3 to the power 3 is equal to a 27. And that is just the value of 3 to the power negative 3. And then we also have b. B says we have to find the exact value of 16 to the power 3 over 4. So let us first make the 16 to the base 2, or change the 16 to the base 2. So to change 16 to the base 2, that will be a 2 to the power 4, because 2 to the power 4 is equal to a 16. So we'll put this in brackets. And then we also have this exponent there, 3 over 4. So now we have these two exponents. When we have these two exponents, we know that we have to multiply. So 4 multiplied by 3 over 4. So we know this 4 will cancel this 4, such that here we will be left with a 2 to the power 3. And 2 to the power 3 is equal to a positive 8. So again, we have C. C says we must find the exact value of cos 30 degrees. We have to find the exact value of cos 30 degrees. Let us sketch our triangle here. And here we'll have 60. Here we will have 30. And here we will have our 90 degrees. So since we know it by heart that sine 30 is equal to a 1 over 2. So that means this is the opposite and this is the hypotenuse. If we were to put it on our triangle, the 1 will be here on the opposite of 30 degrees, and then the 2 will be on the hypotenuse. So to get this other side, you know that c squared is equal to a squared plus b squared, when c is the hypotenuse. So 2 squared is equal to a squared, let us put the 1 squared, plus b squared. And to make b the subject, we would have to take the 1 squared from the right hand side to the left hand side. So we will have 2 squared minus 1. So that is 4 minus 1. So which means it's a 3. Yes, a 3, which is equal to the b squared. To get the b squared, we have to use a square root. So to get rid of the square. So b will be equal to a root 3. So we know that this side will have a root 3. And yeah, the question says we're looking for cos 30, not sine 30. So from our we know that when we want to find the exact value of cos 30, we would have to use this one. So it will be the adjacent over the hypotenuse. So cos 30 degrees will be equal to the adjacent of 30 degrees, which is root 3, over the hypotenuse, which is 2. So this is the exact value of cos 30. And that is just how we do it. Now let us move on to question 14. Question 14, simplify. We have that expression. We have 64 x to the power 12 to the power 1 over 6. So we have to simplify this. So the first step will be to make 64 to the base 2. So 64 to the base 2 is 2 to the power 6. And there's nothing we can do with the x, so it will remain x to the power 12. And this is all to the power 1 over 6. So now that we have something like this, we can still say that this 2 to the power 6 is also to the power 1 over 6. And this x to the power 12 is also to the power 1 over 6. So now that we're here, we know that the powers can multiply each other. So 6 multiplied by 1 over 6, we know that this 6 will cancel the 6, such that here we'll be left with 2 to the power 1. So we don't need to write that one. We know that it's there. So this side we have x to the power 12 to the power 1 over 6. So we know the powers multiply each other. So this 6 goes here once and this 6 goes here twice. So 2 multiplied by 1, that is a 2. So that means we have x to the power 2. And that is our final answer. That is how we simplify this thing, such that we are left with 2x squared. Okay, so we move on to question 15. Question 15. On each Venn diagram, shade the region indicated. So on the first one, we are supposed to shade not A union B. So A union B is this one. But here we are told that we are supposed to shade not A union B. So that means the part that we are supposed to shade is this one. The one which is not A union B, the outer part. And that is just how we do it for the first one. So this statement here actually means not A union B. So that is why we shaded the outer part, because A union B will be this one. But then the question doesn't want this. It wants the not A union B. So for the next question, we have C union D and not E. So it's C union D and not E. All right. C union D and not E. So C union D will be this one, but not E. So that means we cannot shade this part. So it will be this part, which is C union D. But if we were not told about this not E, we were going to shade this part because it's C union D. So that is why we have C union D here and not E, or this part. And that is just how we do it for this question. We move on to the next one, which is question 16. Question 16, find the equation of the straight line passing through -2 and -2, -4, and 2, 0. So we have a straight line passing through -2, -4, and 2, 0. So we have to find the equation of that straight line. So we know that in order to find the equation of a straight line, we have a formula. Y equal to mx plus c, where m is the gradient. So in order to find the gradient, we know that we also have another formula. So for the gradient, we have formula which is like this one. y2 minus y1 over x2 minus x1. Alright, so we will call this x1, y1, x2, y2. So now let us find the gradient. So y2, that is 0, minus y1, that is negative 4. All this is over x2, which is 2 here, minus x1, which is negative 2. So now that we're here, this will be equal to 0 minus negative 4. This changes to a plus. So that is 0 plus 4, which is positive here, positive 4 here. All this is over 2 minus negative 2. Again, this changes to a plus. So that means it's a 2 plus 2. So that is still a 4, which equals to a 4 over 4 is a positive 1. Okay, so that means our gradient is equal to a positive 1. So now we can write our equation like this and say y is equal to a 1 multiplied by x. So we don't necessarily have to write the 1, but we write it as x. We know that it's there, but we don't write it. So it's y equal to x plus c. So now we are left with this c. We have to find the value of c. We will use one of the coordinates to find the value of c so that we can find the y-intercept, because c represents the y-intercept. So we will use 2, 0. So for the y value, we'll use the 0. So 0 will be equal to nx. So x, we substitute with a 2. So plus c. So to find c, we have to take positive 2 from the right hand side to the left hand side. So we'll do that by subtracting 2 both sides. So this will be 0, such that c will be equal to a negative 2. So now that we have our value of c, that means from y is equal to mx plus c, our equation, which is of the straight line passing through these 2 points, is y, let me write it in green, y equal to a and x plus c, which is negative 2. So that means we'll have minus 2. So this is our equation. The equation of the straight line passing through these 2 points is y equal to an x minus 2. And that is just how we do it for this question. Up next, we have question 17. Question 17, rationalize the denominator. So we have 3 over the square root of 5 plus 2. So we're supposed to rationalize this denominator. When they say rationalize the denominator, they mean change the denominator from an irrational number to a rational number, which means to an integer or a simple fraction. Right, so let us rationalize this denominator. To do that, we will have to multiply this fraction with a root 5 minus 2 over the square root of 5 minus 2. Actually, this is a 1 because it's the square root of 5 minus 2 over the square root of 5 minus 2. It's more like 2 over 2. So that is a 1. So why do we choose this? We actually want to get rid of this square root of 5. So because it's the one that makes the whole denominator an irrational number. So let us multiply this. So we have 3 multiplied by the square root of 5 and minus 2. So let's put this in brackets. We have 3 multiplied by the square root of 5, that is, so this is equal to the 3 multiplied the square root of 5. So it's 3 root 5. And we have 3 multiplied by minus 2, so it is minus 6, over the square root of 5 multiplied by the square root of 5, that is a 5. Square root of 5 multiplied by a minus 2, so that is a minus 2 root 5. 2 multiplied by the square root of 5, that is plus 2 root 5. And then we have 2 multiplied by negative 2, or a minus 2, that is a minus 4. So now we have this fraction. So that is 3 root 5 minus 6 over 5 minus 2 root 5 plus 2 root 5 minus 4. So this denominator can still be sorted. And here we will have 3 root 5, which is the numerator, minus 6, over 5 minus 2 root 5 plus 2 root 5, that is a 0. So that means we have 5 minus 4. So that is equal to a 1. All right. So now you can see our denominator is a rationalized one. So we have an integer. So that means our job is actually done here. We can leave it like this or leave it as 3 multiplied by root 5 minus 2 when factorized. It's still the same thing, but that is just how we rationalize the denominator of this fraction. Okay, now let us move on to question 18. Question 18a says factorize. So we are supposed to factorize 3y minus y squared. So we have this expression and we're supposed to factorize. This is actually the easiest expression to factorize. We simply have two terms and we have to find the common factor and factor it out. So here we have a common factor of y. We are going to factor it out and open brackets. So to get 3y, we have to multiply y with a 3. And to get y squared minus y squared, we have to multiply y with a minus y. And that is just how we factorize a. And then we have b. b says we must simplify 3y minus y squared over 9 minus y squared. All right, so to simplify this, I think we also have to factorize. So let us factorize this. The first part is already factorized on a, so we will have y factored out and open bracket 3 minus y. We have already done that on a. And then we have the denominator 9 minus y squared. We are going to factorize there again. So to do that, we know that this is a difference of two squares. So how do we factorize a difference of two squares? First, we will have our two brackets. So here we have 9. So what is the square root of 9? The square root of 9 is a 3. So we'll have 3 here and here. And then we have y squared. The square root of y squared is y. So we'll have y over there and also have y over there. Here we have a plus and here we have a minus. That is just how we factorize a difference of two squares, which is the denominator over here. And then we have this fraction. So from our factorization, we notice something. So this can cancel this because it's because it's multiplication and division. So what are we left with? We are left with y over 3 plus y. And that is just how we simplify this expression. Alright, let us move on to question 19. Question 19 says, find the value of a. We have log 4 over log 8. So we're supposed to find the value of log 4 over log 8. So log 4 over log 8 is the same as log 4 to the base 8. So when we have log 4 to the base 8, that means we have base 8 raised to the power something is equal to a positive 4. So what we are looking for is the power that the base 8 is raised at. So what is that power? Let us call it an x, just for identification. So say we have a power or an exponent of x here, and we want to find that value of x. We would make 8 to the base 2. So 8 to the base 2, that is 2 to the power 3 to the power x, because the 8 is raised to the power x. So this is equal to 2 to the power 2. That is 4 to the base 2. So now we have 2 to the power 3 to the power x. So we know that the exponents, they multiply. So that means we have 2 to the power 3x equal to 2 to the power 2. So now we have the same basis. So that means we can now say 3x is equal to 2. That is from the exponents. So 3x is equal to 2. So to make x the subject, we have to divide by 3 both sides. So this 3 will cancel this 3 such that x will be equal to 2 over 3. But then we just introduced this x for identification. It doesn't mean we are looking for x. So we cannot actually use the x for answering this. We can just use the answer, which is 2 over 3. So log 4 over log 8 is equal to 2 over 3. We just use the x for identifying the power which the base 8 is raised at. So our final answer is 2 over 3. Now on question 19, we also have b. B, we have log 8 to the base 4. Also here, 8 is equal to the base 4 raised to the power something. And we want the power that 4 is raised at. So again, we will let this exponent be an x. And try to identify that exponent using the x. So now we have 4 to the power x. Let us make 4 to the base 2. So 4 to the base 2 is 2 to the power 2. So this is to the power x because it's raised to that exponent. So this is equal to 8. 8 to the base 2 is 2 to the power 3. And then we have 2 to the power 2x because the exponents multiply. All this is equal to 2 to the power 3. Okay, so now we have the same basis. So now we can say 2x is equal to a 3. And make x the subject, we will divide by 2 both sides. This 2 will cancel this one such that x will be equal to a 3 over 2. So that means the power in which this base 4 is raised at is 3 over 2. But we used the x just for identification. So that means log 8 to the base 4 is actually equal to 3 over 2. So this log 8 is equal to a 3 over 2. That is our final answer. And that is just how we do it, ladies and gentlemen. Now let us move on to the final question, which is question 20. All right, question 20, we have g of x, which looks like this. G of x equal to a 2x plus 1 over x minus 1. And the question says, solve the equation whereby the inverse of g is equal to a positive 2. So the first step here will be to find the inverse of g. So we know that the inverse of a certain equation is a reflection through the equation, which is y equal to an x. So how do we find the equation of the inverse of g? So first let us write the equation of g as y equal to that. So y will be equal to 2x plus 1 over x minus 1. So this is the equation of g, and we want the inverse. So to get the inverse, we have to interchange y and x. So where there is y, we will put an x, and this will be equal to 2 of 2x. Where we have an x, we'll put y. So plus 1 over y minus 1. So from this step, we have to make y the subject. So how do we make y the subject? Let us first get rid of the fraction. So we will multiply everything with a y minus 1. So we'll multiply with a y minus 1 here and y minus 1 over there. So this will cancel this, such that we will have x multiplied by y, that will be an xy, x multiplied by a negative 1, that is minus x. All this is equal to 2y plus a 1. All right. Now we have this expression. We have xy minus x equal to 2y plus 1. So I want us to take the x, the minus x, from the left hand side to the right hand side, and also take the 2y from the right hand side to the left hand side. So let's do that. We will first take the x, the minus x. We will do that by adding x here and also add x on the right hand side. So this will be 0. And also we want to take 2y from the right hand side to the left hand side. So we'll do it by subtracting 2y here and also subtract 2y on the left hand side. So what are we left with? We're left with xy minus 2y. This one will be equal to, so this will be equal to a 0. So that will be a positive 1 plus an x. So from here, we have xy minus 2y equal to a 1 plus x. So we have xy minus 2y equal to a 1 plus x. So here, because we want to make y the subject, let us factorize this part. So because we have y as the common factor, we will factor it out. So we will have y, we will factor it out, open bracket, we have x for xy, and to get minus 2y, we will have y multiplied with a minus 2, close bracket. All this is equal to 1 plus x. We're not changing on the other side of the equal sign. So to make y the subject, we will have to divide by x minus 2. And also divide by x minus 2 on the right hand side. So this will cancel this, such that y will be equal to a 1 plus x over x minus 2. So this is the inverse of g. So we can even write it like this. The inverse of g equal to 1 plus x over x minus 2. So this is the inverse. The question said we must solve the equation whereby the inverse is equal to a positive 2. So that means we must find the value of x whereby this is equal to a positive 2. All right, let us use another page for this part. All right, so we want the value of x whereby this inverse is equal to a positive 2. So the next step will be 1 plus x over x minus 2 is equal to a positive 2. So to solve for x here, we'll first get rid of the denominator. So we'll do that by multiplying with an x minus 2. Multiply with an x minus 2 on the right hand side as well. So this will cancel this such that we were left with a 1 plus x equal to a 2x. 2 multiplied by an x, that is a 2x. 2 multiplied by a minus 2, that is a minus 4. Right, so here we have 1 plus x equal to a 2x minus 4. We want to solve for x. So to do that, we will take this plus x from the left hand side to the right hand side. So we'll do that by subtracting x here on the left hand side. So we do that there, we do that on the left, and we also have to subtract on the right hand side as well. Again, we want to take the negative 4 from the right hand side. We'll do that by adding 4 and also add 4 on the left. So now what do we have? We have 1 plus 4. So 1 plus 4 is a 5. And this will be a 0. So this is equal to 2x minus x. That is an x. This is a 0. So that means x is equal to a 5. So to answer our question, the inverse of g is equal to a positive 2 when x is equal to a positive 5. And that is just how we solve this part of the question, ladies and gentlemen. Well, guys and girls, that marks the end of this tutorial. Make sure you join us again, same time, same place next week for another Cambridge Mathematics video tutorial. Remember to subscribe to the channel if you haven't done so already, so that YouTube can let you know whenever a new video has been uploaded.